Today's lesson is over three special types of parallelograms. We have a rhombus, a rectangle, and a square. A rhombus is just a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. And a square is a parallelogram with four congruent sides and four right angles. So a square actually falls under the category of a rectangle and a rhombus. First, we have two theorems for a rhombus. Theorem 613 says that if a parallelogram is a rhombus, then its diagonals are perpendicular. And remember, perpendicular means they meet at a 90-degree angle. Theorem 614 says that if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Now remember, bisect means it cuts the angles in half. Cuts the angles in half to where we have two congruent angles. So if you look at the picture, we look at, diagonal AC. That means diagonal AC bisects angle A, where angle 1 is congruent to angle 2, and it bisects angle C, to where angle 5 is congruent to angle 6. Diagonal BD bisects angle D, to where angle 3 is congruent to angle 4, and it bisects angle B to where angle 7 is congruent to angle 8. We are going to use these two theorems to find missing angles of a rhombus. This is very similar to when we found missing angles of a kite. So first of all, we are trying to find angle 1, angle 2, angle 3, and angle 4. And we know that the diagonals of this rhombus not bisect each other. They are perpendicular. My apologies. So if they are perpendicular, we know that these four angles in the middle where the diagonals meet are all 90 degrees. So that means that angle 1 is 90 degrees. We know that from our theorem. We also know from theorem 614 that angle 2 is congruent to angle 3 because the diagonal BD bisected that angle. And we know that angle 4 is congruent to this angle. So I could also call this angle 4. So I can use this triangle right here to find the measure of angle 4. If I know that the sum of the angles of a triangle is 180, then angle 4 plus 90 plus 58 should be equal to 180. And then we could solve for angle 4. So 90 plus 58 gives us a 148. Subtract that from 180, and we find that the measure of angle 4 is 32 degrees. this is 32 degrees. There's a few different ways you could figure out the measures of angle 2 and angle 3. We could use the same method we just used. So since we know that angle 1 is 90 degrees, and we now have the measure for angle 4, we could look at this smaller triangle to find the measure of angle 3. So the measure of angle 3 plus 90 plus 32 degrees should be 180. There are 180 degrees in a triangle. So to find the measure of angle 3, to find the measure of angle 3, you would add 90 and 32, which would give us 122. And subtract that from 180. So the measure of angle 3 is that's not right. 58. My apologies. And if the measure of angle 3 is 58 degrees, that means the measure of angle 2 is also 58 degrees because they are congruent. And I want to point something out. If we look at this as a parallelogram, we know that these two lines are parallel. And this is kind of like our transversal. Notice that the angle marked with the 58 degrees and angle 2 are alternate interior. And if we have parallel lines, which we know we have parallel lines because this is a parallelogram, then we know alternate interior angles are congruent. So it makes sense that angle 2 turned out to be 58 degrees. Right. We have another one. On this rhombus, we are only given one of the diagonals. But from our theorem, we know that angle 3 is congruent to angle 4, and angle 1 is congruent to angle 2. If I look at this as a parallelogram, I know that consecutive angles are supplementary. So that means that 104 plus the whole angle R, which is angle 3 plus angle 4, should be equal to 180. Now, we also said that angle 3 and angle 4 were congruent, meaning that they had equal measures. So I'm going to call angle 3 x, and that means angle 4 is also x. So 104 plus 2x equals 180. Then I could subtract the 104. So 2x is equal to 76. And then divide by 2. So x turns out to be 38, which means angle 3 is 38 degrees, and angle 4 is 38 degrees. So now if I want to find angle 1 and angle 2, we could do the exact same thing we did here. Because we know that 104 plus the angle P is also going to be equal to 180. So if we did that, we would get the exact same answer. Now I'm just going to call angle 1 y, and if angle 1 is y, then angle 2 is y, because they are congruent. So this gives us a 104 plus 2y. Then we would subtract the 104, so 2y is equal to 76, and we would divide by 2. So exact same answer. Oops. If we use the other method, remember RS and QP are parallel lines. So if angle 3 and angle 4 are both 38 degrees, then the alternate interior angles are also 38 degrees. There's multiple ways of solving these. Now we have a theorem for rectangles, theorem 615. And it says if a parallelogram is a rectangle, then its diagonals are congruent. So we have one example for this. In rectangle RSBF, SF is equal to 2x plus 15, and RB is congruent or is equal to 5x minus 12. What is the length of a diagonal? Sorry. So SF is 2x plus 15, and that's this line right here. And RB is this line right here. So we have the two diagonals of our rectangle. And our theorem said that in a rectangle, our diagonals are congruent. So that means I can set these two expressions equal to each other. So 2x plus 15 equals 5x minus 12. And then we would solve for x. So subtract the 2x first to get all of the x's to one side. So 15 equals 3x minus 12. Add the 12 to the other side. So 3x is now equal to 27. And then divide by 3. So x is 9. Now it asked for the length of a diagonal. To find the length of a diagonal, let's say we want to find SF. Since SF is 2x plus 15, we can plug our x value in. So 2 times 9 is 18, plus 15 gives us a 33. Now we could stop there, but to check our answer, we could also go ahead and plug it into RB. And we know that we should get the same answer because our diagonals should be congruent. So RB is 5x minus 12. So 5 times 9 minus 12, which also gives us 33. And that is all I have for you guys today.